In this video, we'll look at solving quadratic equations through factorising and also through using the quadratic formula. A quadratic equation is one which has a variable whose greatest power is 2. The quadratics have several components that we'll be referring to throughout this video, so we'll quickly go through them now. A quadratic can usually take this form, but the only part that it needs to be considered a quadratic equation is a variable to the power of 2. And no greater power. The coefficient of that x will always be referred to as the a coefficient. If it does have a second x with a power of 1, its coefficient is called the b coefficient. And the final number is called the c coefficient. As with linear equations, the c coefficient is also referred to as the y-intercept, as it's the only value of left when the value of y is 0, and it's where it crosses the y-axis. When we talk about solving quadratic equations, it's important to understand that it means finding the values of x when y equals 0. We know that if the product of a multiplication is 0, it means that one of the factors of that multiplication must have been 0. Here we have a factorised equation, meaning it's in brackets and that these brackets will be multiplied together. We're going to look to expand these brackets, and I'll be using this grid to show you how I'm doing that. Although I'm using the grid method to factorise further quadratics in this video, I would usually use the FOIL method, which stands for first, outer, inner, last, and refers to the order in which you multiply out the brackets. Using this method means that they are in order for all the like terms to be collected. First, I'll show you this order and then move to the grid as a better way to display how I'm working this in my head. When we talk about the FOIL method, we're talking about the first terms in each of the sets of brackets, then the outer terms in the two sets of brackets, so the x and the negative 5, then the inner terms, so the minus 2 and the x, and then the last two terms in either of the brackets, negative 2 times negative 5. So if we do these in order, we get x times x, which gives us x squared, x times negative 5, which would give us negative 5x, negative 2 times x, which would give us negative 2x, and negative 2 and negative 5, which give us positive 10. Negative times negative gives us a positive. We can then combine these two like terms that are in the middle to get x squared minus 7x plus 10. Now I'll show you how I do that using the grid method, because we're going to use this to expand these equations later on. So here I'm going to write x minus 2 in the squares above here, and x minus 5 here. Now we know that finding the area of a square would be multiplying the two sides together, so that's what we're going to do here. So we've got x times x, which gives us x squared. We've got negative 2 times x, which gives us negative 2x. We've got negative 5 times x, which gives us negative 5x. And we've got negative 2 times negative 5, which gives us positive 10. So here, we could expand this out of the grid by combining these two terms in the middle. Sometimes this is called drawing the peanut. So we read this from the top left corner to the bottom right corner. X squared, combine the two terms in the middle to get negative 7x, and then the last one, which is plus 10, which we put on the end. So you can see we get the same equation out of both of these methods. Now, let's look at an equation where we're actually trying to solve it using this factorisation. In this next problem, we've got x squared plus 6x plus 8 equals 0. And as I've said, we'll use the grid method for the moment. We've spoken before about factors and their importance in much of maths we're covering. And this is very true of quadratics. The two parts of the equation that we can enter straight into our grids is the x squared in the top left and the c coefficient in the bottom right. We know that the c coefficient is the result of two numbers being multiplied together. So we need to look at all the factors of that number. We can also use whether it's positive or negative to understand the polarity of these numbers. Positive meaning they're both the same polarity, or negative meaning they're different. So now we need to write up the factors of 8, which is 1 times 8 and 2 times 4. Now we know that in order to gain the b coefficient of positive 6, we'll be adding one of these pairs of factors together. So which pair will give us the sum of 6? We can see it'll be the 2 and 4. We can now look to complete the grid using this information. So here we can put x plus 2 at the top and x plus 4 on the left. So 2 times x would give us 2x, and 4 times x would give us 4x. So we can double check that by adding the peanut we get x squared plus 6x plus 8, which is correct. So we can actually write these as two sets of brackets now. What's on the top of the grid and what's down the left-hand side. So left-hand side we have x plus 4, and at the top we have x plus 2. Remember that this equation equals 0, so one of these sets of brackets has to equal 0 for this to be solved. In order for x plus 4 to equal 0, x is going to have to be negative 4. In order for x plus 2 to equal 0, x would have to be negative 2. So either of these can be our answer for x. We need to make sure that we state both of them, and then it can be either or. In this next equation we have x squared minus 7x plus 12 equals 0. Here I'm going to use the grid method again, but you can use for method if that's what you're used to. Pause the video now and press play when you'd like me to calculate the answer. As you can see with this one, the c coefficient is positive, so we know that both the factors were either positive or negative. As the b coefficient was negative, we could safely assume that both of the factors are negative, to add to give a negative number. Here, we find the factors of 12. 12 is positive, but we know that the factors are all going to be negative because they're going to multiply together to make a positive number, but add together to make a negative. We want to make negative 7. Negative 1 times negative 12 would give us positive 12. Negative 3 times negative 4 would also give us positive 12. But that's the one that actually, when they add together, would get negative 7. So we can bring that across to our grids. We can write in x squared in the top left and 12 in the bottom right. And we know we can write x above and to the left of where the x squared is, and we can write minus 3 in the top and minus 4 in the bottom left. And we can double check this by multiplying the grid to get minus 3x and minus 4x. If we draw that peanut around them, we're going to get that b coefficient of negative 7x. So we know our answers are right. We can now put this into brackets, and we get x minus 3 in the first bracket, and in the second bracket, x minus 4. Remember, this equation equals 0. Therefore, to make the first bracket 0, x would have to be 3, and to make the second bracket 0, x would have to be 4. So we can give the answer to this equation, x would equal 3 or 4. In the next equation, we have x squared plus 14x minus 51. We can see that the c coefficient is negative, which means that one of the factors of b51 will be positive and one will be negative. As the b coefficient is positive, it tells us the smaller number is the negative one of these two numbers, because it adds together to make a positive number. Pause the video here to work through the answer and press play when you'd like me to go through it. So here we need to find the factors of negative 51. Because this is negative, but yet our b coefficient is positive, we know that the smaller of the two factors will be negative. So we can say minus 1 and 51, and minus 3 and 17. The minus 3 plus 17 would give us the positive 14, which is our b coefficient, so those are the two factors that we're going to choose. We can put this into our grids. X squared and minus 51 can go in there. And we can put x minus 3 at the top and x plus 17 at the bottom on the left-hand side. If we were to calculate these values of x, minus 3x would go in the top right and 17x would go in the bottom. We could draw that peanut around them, add them together to get 14 as a double check. In the first set of brackets, we're going to write x minus 3 because that's our expression that's at the top. And in the second set of brackets, we're going to write x plus 17 because that's our expression on the left-hand side. So in order for the first set of brackets to equal 0, x would have to equal 3. And in order for the second set of brackets to equal 0, it would have to be negative 17. So we can say that our answers are x equals 3 or negative 17. In this next equation, we don't have a b coefficient. These quadratics come up quite often, but they're very easy to spot when you know what to look for. You'll see the symbol here is always negative. in front of the c coefficient, which is always the result of squaring a number. There's a reason for this, and I'll show you why. Firstly, before, we need to find the factors of 100. So we create the factors of negative 100. We've got negative 1 times 100, negative 2 times 50, negative 4 times 25, and negative 5 times 20, and finally negative 10 times 10. We knew we were going to look for a squared number, so this one's going to be it, because negative 10 plus 10 would equal 0. We can write that into our grids. Y squared goes in the top left-hand corner, negative 100 goes in the bottom right. If we were to write minus 10 at the top and plus 10 on the left-hand side, we could calculate that to be negative 10x and positive 10x. And if we combine these two together, we just get 0x. So it doesn't get written. We also have two sets of brackets. We know we're going to have y minus 10 because that's our equation from the top, and y plus 10 because that's our expression down the side. So y will equal 10 or negative 10. As we know, one of these sets of brackets has to be 0 as a factor of this multiplication to get the product of 0. Next, we'll look at solving quadratic equations which have an a coefficient valued at greater than 1. We're going to expand the equation to allow us to split the b coefficient of 23, and we'll write our 5x squared over here and plus 12 over here. Next, we need to know what the a coefficient multiplied by the c coefficient is. We can consider that we've always skipped this step in the other quadratic equations as the value of a was always 1 and didn't change the outcome, so we didn't bother to do it. In this one, the product of 5 and 12 is 60. So we need to find all the factors of 60 over here. So we need to find the factors of 60. So we've got 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. Now we know that the b coefficient is 23, so I want the two factors that are going to add together to make 23. So that's going to be 3 and 20. Before we put these in, we want to consider the factors of each and whether they'll go better with the 5x squared or with the 12. As 20 shares more factors with the 5 and 3x shares more factors with the 12, we'll write them as follows, with the 20x next to the 5x squared and the 3x next to the 12. Now we'll factorise these two expressions, and we're looking for a set of brackets which has the same values inside them. Here, both can be factorised to get x plus 4. As both expressions have x plus 4, we can now combine the terms outside of the factorised brackets to create the second set of brackets as follows, which is 5x plus 3. So now we have x plus 4 and 5x plus 3. You must remember that this equation equals 0. So we calculate what our values of x are for each of the set of brackets to equal 0. In this bracket, I need to consider what x could be to multiply by 5 to make it negative 3, so that'll be negative 3 over 5. So here we've got the answers of x equals negative 3 over 5 or negative 4, because that would equal 0 in the other set of brackets. Next, we'll move on to solving quadratic equations through the quadratic formula. And we have this equation, 3x squared plus 4x minus 5 equals 0 to solve. A common clue as to whether or not to use the quadratic formula or factorising to solve for x is to look at how they want the answer. If they're asking for the answer to be rounded to a certain decimal places or significant figures, it's very likely you'll be using the quadratic formula. Let's remind ourselves first what form a quadratic equation tends to take, which is ax squared plus bx plus c equals 0. Now we're going to use the quadratic formula, which is worth noting down somewhere where you'll be able to refer to it. The quadratic formula looks like this. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. So what we need to do is we need to know what our values for a, b and c are, and it's worth noting them down. In this equation that we have, the a coefficient equals 3, the b coefficient equals 4, and the c coefficient equals negative 5. So now it's a case of substitution for a, b and c. Ensure you've paid close attention to any negative numbers and how the formula will, for instance, mean that having a negative b value will turn it into a positive for the first part of the equation. So we'll substitute those values in to the equation like this. Minus 4 plus or minus the square root of 4 squared minus 4 times 3 times negative 5. And all of that will be over 2 times 3. So next we can simplify what's underneath the square root symbol and get negative 4 plus or minus the square root of 16 plus 60 over 6, which we can then simplify to be negative 4 plus or minus the square root of 76 over 6. At this point, it's really important for us to understand that if we have a negative number underneath the square root symbol, you're not going to be able to calculate an answer through the quadratic formula. The reason for this is there isn't a square root of a negative number, because it means that a number has to be multiplied by itself to get that. So now we can calculate it. If you're using a calculator, it's worth doing it to this point, as the calculator will allow you to either plus or minus to gain an answer, and then go back using that central toggle button and change the other symbol for the second value of x. So if we calculate the answer, we get 0.78 or negative 2.12. When rounded to one decimal place would mean that x will equal 0.8 or negative 2.1. Here we have an equation that requires the use of the quadratic formula. So pause the video now and press play when you'd like me to go through the answer. So in order to solve this, we need to know what each of the coefficients are. A equals 3, B equals minus 10, and C equals positive 4. We can substitute those into the equation like this. X equals 10 plus or minus 10 squared minus 4 times 3 times 4 over 2 times 3. We can then simplify that to be x equals 10 plus or minus the square root of 52 over 6. If you calculate this on your calculator, you'll end up with 2.868 or 0.465. And that, rounded to two decimal places, will give us x equals 2.87 or 0.47. In this video, we went through solving quadratic equations using factorising and also using the quadratic formula. Remember, in most cases, you'll get two answers, and if they're asking for the answer to be rounded, then use the quadratic formula. In the next video, we'll be looking at sequences and patterns of numbers, and I'll see you then.